Welcome to this lecture on Coloring of a Graph by Dr. Rajesh Singh.
Good afternoon, everyone.
Good afternoon, sir.
Good afternoon, Shakshi. So in the last class, we defined subgraph and then we also did some types of graphs, right? We did null graphs and we defined complete graphs, right?
Yes, sir.
What was the definition of null graph? Graph with no edges, right? Null graph was graph with no edges. That is, every vertex in a null graph is an isolate vertex, or every vertex in the null graph is of degree 0. Okay. And what was the complete graph? What was the definition of complete graph?
Every pair of vertices are adjacent.
Yes, every pair of vertices are adjacent. That is the maximum possible edges that can exist in a graph of order n, right? And what was the maximum number of edges that can be there in the graph? It is nc2. Number of edges in Kn is nc2, right? So now today we will define bipartite graph. Okay. So let us start again. So types of graphs. So we have already done null graphs in which no two vertices are adjacent. Okay. First is null graph. No two vertices are adjacent. That is graph of order n and size 0. Okay. And then we did complete graph in which every pair of vertices are
Adjacent.
adjacent. Okay. So complete graph of order n is denoted by complete graph of order n is denoted by Kn. So number V of Kn, number of vertices in Kn is n, and number of edges in Kn is nc2. Okay. Is it fine? Now third type is bipartite graphs. Okay. Bipartite graphs. So what do you understand by this term bipartite? क्या लग रहा है, क्या होना चाहिए definition? मतलब bipartite से क्या समझ आ रहा है कि we can partition something into two parts, right? We can partition something into two parts, right? Bi means two and partite means partition, right? So bipartite, by definition, a bipartite graph is a graph G whose vertex set Vg can be partitioned into two sets V1 and V2, that is Vg is equal to disjoint union of disjoint union को इससे भी represent करते हैं disjoint union of V1 union V2. So disjoint union. So union of into two sets such that क्या होना चाहिए? Every edge joins a vertex in V1 and a vertex in V2. Every edge in EG joins a vertex in V1 with a vertex in V2. So basically क्या है कि कोई भी edge होगा तो उसका एक end point will lie in V1 and another end point will lie in V2. So in other words, a bipartite graph is a graph G whose vertex set Vg can be partitioned into two sets V1 and V2 such that the induced subgraph of V1 and induced subgraph of V2 are null graphs. Okay, that is, they have no edges in them. Is it fine? So this is also a definition that the subgraph induced by V1 and subgraph induced by V2 are null graphs. That is, they don't have any edges in them. So सारे edges जो हैं वो V1 और V2 के बीच में लाई कर रहे हैं. ठीक है? So if you have this, so this is V1, this is V2, and all the edges will lie in this. So like this. Okay, so every edge will lie in this. Okay, so this is how it will be. So V1, V2. ठीक है, is that fine? So इस तरह का ग्राफ होगा. चलो एक और को कनेक्ट कर देते हैं, इसमें हम इन दोनों को भी कनेक्ट कर देते हैं. ठीक है, so this is how you can have is it fine? Definition of bipartite graph. Then we have complete bipartite graph. Complete bipartite में क्या होगा? Yes, bipartite है और complete है, so क्या होना चाहिए उसके बीच में? So a bipartite graph with bipartition V1 V2 is said to be a complete bipartite graph if every vertex in V1 is adjacent to every vertex in V2. ठीक है, यहाँ पे क्या है, कुछ vertices if you see, then this vertex is not adjacent to this vertex, right? So there are some vertices which are not adjacent, but here in this every vertex in V1 should be adjacent to every vertex of V2, right? तो उसे complete bipartite कह देंगे. For example, and so a complete bipartite graph with bipartition V1 V2 is denoted by KMN, where cardinality of V1 is equal to M and cardinality of V2 is equal to N. So agar if you can partition the set into two disjoint set of cardinality m and n, then complete bipartite graph will be denoted by kmn, right? Is it fine? Is this notation clear?
Yes, sir.
Yes, sir.
Okay, fine. So let us take an example for this. So let us take an example for K3 4. So K3 4 में क्या होगा? There will be two partitions V1 V2. इसमें तीन elements होंगे. So three vertices we can draw. ठीक है? And यहाँ पे we will have four vertices. So V1, V2, V3, V4, V5, V6, V7. So total 7 vertices are there, and then we will join. So this V1 should be adjacent to every vertex in V2, right? Similarly, V2 should be adjacent to every vertex in this, and similarly your V3 should be adjacent to every vertex in this. Right? Is it clear?
Yes, sir.
Okay, now give me these important observations. About complete bipartite graph. So first is for the complete bipartite KMN, complete bipartite graph KMN. First, what is the cardinality of KMN? Order of this graph. बताओ क्या होगा? Then number of edges in KMN, ये क्या होगा? For each V belonging to V1, degree of बताओ जल्दी जल्दी इनके आंसर. सिंपल है.
Sir, VKM comma n equals to cardinality of VKM comma n equals to m plus n.
Yes. What about this number of edges?
Sir, it's equal to n plus n up to so on m times m into n.
Yes, mn. ठीक है ना? Yes. क्योंकि इसमें देखो क्या हो रहा है. बेसिकली हर एक वर्टेक्स के कोरस्पॉन्डिंग कितने एजेस आ रहे हैं जितने इसमें है, राइट? सो इसके कोरस्पॉन्डिंग n आए, इसके कोरस्पॉन्डिंग n एजेस आ गए, इसके कोरस्पॉन्डिंग n एजेस, सो टोटल mn एजेस, राइट? Now what about this degree of vertex v in if v is in v1?
N.
ये क्या होना चाहिए? n, जितने नंबर ऑफ वर्टिसेस v2 के अंदर है क्योंकि वो सारे एडजेसेंट है v से, राइट? एंड सिमिलरली डिग्री ऑफ u क्या हो जाएगा?
M.
m. ठीक है, so these are some simple observations from this about complete bipartite graph. So let me just give you a figure. So this is K23, this is K33, this is just a bipartite graph. A bipartite graph of order 6 and size साइज कितना है इसका 1 2 3 4 5 6 7 7 राइट. Not complete. So this one is not complete और बाकी दोनों complete bipartite graphs हैं. These are all complete bipartite graphs. So यहाँ पे जो तुम्हारा bipartition है वो ये वाला ले रहे हैं, दो bipartition. ठीक है. So this is one bipartition, this is another bipartition. Is it fine? So all these are bipartite graphs. ठीक है. Is it fine, everyone?
Yes, sir.
Okay, now we are going to define a new concept which is coloring of a graph. बाकी अगर कोई अभी तुम्हारे सिलेबस में यही 3 टाइप्स ऑफ ग्राफ्स हैं, तो ये 4 टाइप्स, बाकी और टाइप्स बीच बीच में आएंगे तो वी विल स्टडी देम. Coloring, or it is also called proper coloring. So let us just define this. Definition: a proper coloring of a graph is an arrangement of colors is an assignment of colors to vertices of the graph in such a way that no two adjacent vertices of the graph receive the same color. Okay, so you have to color the vertices of the graph in such a way that no two adjacent vertices of the graph receives the same color. Okay, is it fine? Is this definition clear?
Yes, sir.
Okay, so let us take some examples for this. Example, let me just draw this graph. Let me take this graph where my vertices are this. So I can give a proper coloring. Okay, so I can give this a color this. क्या color दे सकते हैं? We can give it, okay, just so blue color, then make it red, then make it say orange, then make it yellow. So this is a proper coloring, right? Proper coloring with 4 colors. Okay, so we have used 4 colors here, right? Because no two adjacent vertices have the same color. We can also color it using this. Another proper coloring. So now give me the colors with minimum number of colors that you can use. कितने colors use होंगे minimum? Yes. 2. कौन कौन से?
3.
2 से हो जाएगा बेटा. इन दोनों को देखो, these are two non-adjacent, so you can give them 2 colors. These are two non-adjacent, so you can give them 2 colors, right? 3 की जरूरत नहीं पड़ेगी. So these are non-adjacent, so I have used one color. Then I can use another color because these are non-adjacent, so I can give them proper coloring with two colors. Okay, is it fine? So maximum how many colors you can use to give this a proper coloring?
4.
4. जितने भी किसी भी ग्राफ में जितने भी वर्टिसेस हैं उससे ज्यादा तो यूज नहीं कर सकते तुम कलर, राइट? एंड मिनिमम के लिए डिपेंड करेगा ग्राफ के ऊपर. यहाँ पे 2 थे, किसी में ज्यादा भी हो सकते हैं, किसी में एक भी हो सकता है, डिपेंड्स टोटली. जैसे अगर सारे आइसोलेटेड वर्टिसेस हैं ग्राफ के अंदर, अगर नल ग्राफ है तो उसमें एक ही कलर से तुम्हारा वो हो जाएगा. मिनिमम नंबर ऑफ कलर वुड बी 1 फॉर प्रॉपर कलरिंग बिकॉज देयर आर नो एडजेसेंट वर्टिसेस. और अगर तुम्हारे पास कंप्लीट ग्राफ है तो उसमें कितने कलर्स लगेंगे? यस, observations.
N.
Yes. First, for any graph of order n, the maximum colors that can be used in a proper coloring is कितने maximum use कर सकते हैं? N, right. Second, for a null graph of order n, the minimum number of colors that can be used in a proper coloring is
1.
reason.
No two vertices are adjacent.
Since in a null graph no two vertices are adjacent, so we can give the same color to all the vertices of the null graph, right? Yes. Now third, in complete graph Kn, the minimum number of colors that can be used in a proper coloring is कितना होगा?
N.
And why?
Each pair of vertices are adjacent, so we have to give different colors to all the vertices.
Yes, since every pair of vertices in Kn are adjacent, so every vertex must receive a different color. Hence, to color n vertices, we will have to use n different colors. Fine. What about complete bipartite graph? Or in complete bipartite graph KMN, the minimum number of colors required in a proper coloring is कितना होगा? Yes. Two. Why? अब रीजन सोचो क्या होना चाहिए? Since for the bipartition V1 V2 of KMN, V1 and V2 are null graphs, so we can give one color to all the vertices of V1, right? And another color to all the vertices of V2, and it will form a proper coloring. Right? Is it clear? अब जैसे ये है यहाँ पे देखो, if you look at this complete bipartite graph, so you can give one color to these two vertices, कोई फर्क नहीं पड़ेगा क्योंकि they are non-adjacent. Similarly, you can give another color to these three vertices. So, ठीक है? Is it fine? So you just need two colors to give a proper coloring to a complete bipartite graph. Is it fine?
Yes, sir.
तो bipartite graph हो गया, complete bipartite graph हो गया, ठीक है. अगर bipartite graph है तो क्या करोगे?
Sir, उसमें भी we can give one color to V1 and different color to V2.
Yes. In fact, we have a theorem for this. A graph G is a bipartite graph if and only if the minimum number of colors required in a proper coloring of G is 2. Okay, if minimum number of colors required in a proper coloring of G is 2, then that graph has to be a bipartite graph. Okay, so let us try to write its proof. So this is the first result that we are doing, right? First theorem. Yes. The graph G is a bipartite graph if and only if the minimum number of colors required in a proper coloring of G is 2. Yes, बताओ what should be it? So suppose G is a bipartite graph. Suppose G is a bipartite graph with bipartition V1 and V2. Then as V1 and V2 are null graphs, right? So we can give same color to all the vertices of V1 and another color to all the vertices of V2. Thus, we will have a proper coloring of G with two colors, right? और वन कलर क्यों नहीं यूज कर सकते? हमें क्योंकि मिनिमम बताना है, तो वन क्यों नहीं यूज कर सकते बताओ? क्योंकि J is not a null graph. Since G is not a null graph, so we need at least two colors for a proper coloring. ठीक है, so minimum number of colors is 2. Hence the minimum number of colors in a proper coloring of G is अब कन्वर्स बताओ. Conversely, let the minimum number of colors required in a proper coloring of G is 2. ठीक है, so उसके बाद क्या करेंगे? अब हमें दो पार्टीशन करना है वर्टेक्स सेट को, तो किस तरह से पार्टीशन करेंगे हम?
Vertices with same color we will put in single set.
Yes.
In the same set.
Yes. So इसके लिए क्या करेंगे? Let V1 be the set of vertices with one color and V2 be the set of vertices with color number 2. ठीक है, color 1 color 2 ये कर देते हैं. ठीक है, then clearly Vg is equal to V1 union V2. Also, since in a proper coloring no two adjacent vertices, in a proper coloring no two adjacent vertices receive the same color, so V1 and V2 are null graphs, right? Is it right? क्योंकि कोई भी adjacent vertices रिसीव नहीं करता सेम कलर, और V1 में सारे vertices हैं with same color and V2 में भी सारे vertices हैं with same color, so they have to be null graphs. So hence G is a bipartite graph. Is it fine? Is it clear, everyone?
Yes, sir.
Question: show that the following graph is a bipartite graph. Because this is a graph, we have to show that it is bipartite. So how we will show that? Let us try to give it a proper coloring. Okay, so let us try to give it a color. So one को suppose we have given red color. अब वन से जितने भी एडजेसेंट है उनको we have to give different color. ठीक है, राइट? या पहले उनको दे देते हैं वन कलर. किस किस को दे सकते हैं हम? वन से कौन सा एडजेसेंट नहीं है? 3 एडजेसेंट नहीं है, राइट? So we can give a red color to 3 also. Then 1 से 5 भी एडजेसेंट नहीं है और 1 से 3 से भी 5 एडजेसेंट नहीं है. So we can give color 5 and then 5 से 7 नहीं है, 7 1 से नहीं है, 7 3 से नहीं है. So we can still give red to 7, right? Is it fine?
Yes, sir.
अब let us give another color क्योंकि अब तो सारे एडजेसेंट रह गए. So let us give 2 2 को green दे दिया, then we can give green to 4 also. अब 2 और 4 से कौन सा adjacent नहीं है? This 6. So we can give, अब इन तीनों से कौन सा adjacent नहीं है? That is 8. So we have seen that. So since we are able to give, we are able to have a proper coloring of G with 2 colors. So G is a bipartite graph. ठीक है? So this is how also you can show. और इसका bipartition भी दिखा सकते थे. 1 3 5 7 एक ले लेते और 2 और 3 3 6 oh sorry 2 4 6 8 दूसरा ले सकते थे. Alternate proof. इसको ये कर सकते थे. You could have taken 2 bipartition. इसको रीड्रॉ कर सकते थे. इसमें क्या क्या लेना है हमें? वैसे दिस कलरिंग इज अ बेटर ऑप्शन. तो सेम ही ग्राफ को कलर करना है तुम्हें. सो 1 3 5 7 1 3 5 1 3 5 7 और दूसरे में 2 4 6 8 1 3 5 7 2 4 6 8. Yes. Now just join them. So 1 is adjacent to 2. ये दिया हुआ है हमें. And then next क्या दिया हुआ है? Yes. One is adjacent to 2, then one is adjacent to 4 also, and one is adjacent to 8 also. ठीक है? One is adjacent to 4, one is adjacent to 4, and one is adjacent to 8. Then what about next vertex? 3. 3 is adjacent to 2, 4, and 6. 2, 4, 6. 3 is adjacent to 2, 4, and 6. Right? And then 5. 5 is adjacent to 6, 4, 8. And 7. 7 is adjacent to 8, 6, and 2. 8, 6, and 2. अब कोई एजेस रह गए? इसके 3, इसके 3, इसके 3, इसके 3, इधर भी. एंड इफ यू सी 2 की डिग्री 3 है, 4 की डिग्री 3 है, 6 की डिग्री 3. So, कोई भी एजेस नहीं रहे हैं. ठीक है? वी हैव कवर्ड ऑल द एजेस. सो वी कैन सी दैट v1 v2. So we can see that v1 v2 forms a bipartition of graph G. Hence G is a bipartite graph. वैसे coloring is a better option. क्योंकि coloring में उसी ग्राफ में कलर करने, right? So you can use 2 different colors. एग्जाम में ब्लू और ब्लैक यूज कर लो पेपर पे लिखने के लिए. ठीक है? Is it fine?
Yes, sir.
Is it clear, everyone? So,
Yes.
okay, fine. So is this graph a complete bipartite graph? Is this graph a complete bipartite graph?
No, sir, it is not.
No.
Is this a complete bipartite graph? No, not a complete. Why? Yes.
Degree of any vertex in V1 is not equal to the order of V2.
Yes. Degree of 1 is equal to 3, which is less than 4. Okay. The cardinality of V2. Okay. So इसलिए, or you can easily say that 1 is not adjacent because 1 is adjacent to, sorry, 1 is adjacent to 2, 4 and 8, but it is not adjacent to 6. 1 is not adjacent to 6, which belongs to the other set, right? So कुछ भी reason दे सकते हो, बहुत सारे reasons हैं हमारे पास. Okay, fine. So let us just do the first theorem of this graph theory, which was given by Euler when he was disproving that Königsberg bridge problem, right? So he gave this very important theorem. So a theorem करके then we will end today. So this is Euler's theorem. The sum of the degrees of the vertices of a pseudograph is an even number and that is equal to twice the number of edges. मतलब कि sum of degrees of vertices is equal to twice the number of edges. Can you give a reason for this? Why it should be? जैसे अगर हमारे पास simple से graph ले लें, if I take this graph, okay, if I take this graph, so this is our V1, this is our V2, this is our V3, this is our V4. So degree of V1 is, in fact, degree of Vi is 2 for each I equal to 1, 2, 3, 4, right? Yes. So sum of degree of Vi, sum of degree of Vi क्या हो गया? Yes, what is this? 2 plus 2 plus 2 plus 2, which is 8, which is 2 into number of edges, right? So this is the theorem. So why it is happening? अगर देखो, if you look at this edge is being counted in degree of V1 also, and this edge is being counted in degree of V2 also, right? देखो, degree of V1 is number of edges incident with V1. Degree of V1 क्या है हमारे पास? Degree of V1 is number of edges incident with V1, and degree of V2 is number of edges incident with V2. ठीक है, और सबको ऐड करोगे तो क्या होगा? जो ये दोनों जो edges हैं, this edge is being counted twice in the number of in the degree of this, right? It is being counted in degree of V1 also, and it is being counted in degree of V2 also. ठीक है, degrees is nothing but number of edges incident with that vertex. So हर एक edge जो है वो दो vertex के incident होता है, right? Every edge is incident with two vertices, right? Right?
Yes, sir.
तो इसलिए ये ट्वाइस हो जा रहा है क्योंकि हर एक एज जो है वो दो उसके साथ कंट्रीब्यूट कर रहा है. इट इज बीइंग काउंटेड इन 2 डिग्रीज, इसलिए ट्वाइस आ रहा है हमारे पास, क्योंकि डिग्रीज आर नथिंग बट नंबर ऑफ एजेस. जितने भी ग्राफ में एजेस है उनको ही ऐड कर रहे हैं हम. Okay, so that's why this result is there. So let us try to write its proof in our language. Now for each vertex v, since degree of v is equal to number of edges including multiple edges incident with v plus twice the number of loops इंसिडेंट विद वी, बल्कि ये नंबर ऑफ एजेस ही ले रहे हैं लूप्स को भी, ठीक है, लूप्स को भी दे आर कंसीडरिंग नंबर ऑफ एजेस इंक्लूडिंग मल्टीपल एजेस एंड लूप्स. Note, each loop is considered to be incident with a vertex two times, ठीक है, since each loop adds 2 to the degree of the vertex, ठीक है. Now since each edge is incident with two different vertex, and each loop is considered to be incident with same vertex twice, hence in summation of degree v, each edge is counted twice, right? ठीक है ना, क्योंकि हर एक एज जो है वो दो के साथ इंसिडेंट है, तो जब समेशन डिग्री लेंगे तो एक बार अगर दो हमारे पास डिफरेंट वर्टेक्स हैं v और u, तो एक बार v के में भी काउंट हो जाएगा, एक बार u में भी काउंट हो जाएगा. सो ईच एज इज काउंटेड ट्वाइस, हेंस summation degree u is equal to twice the number of edges. ठीक है, is it fine? Is it fine? Everyone, is the proof clear?
Yes, sir.
ये बुक की लैंग्वेज होगी, ठीक है. So if you see that adding the vertices of all the vertices involves counting one for each edge incident with each vertex. How many times does an edge get counted? If it is not a loop, it is incident with two different vertices, so gets counted twice, one at each vertex. On the other hand, a loop with a vertex is also counted twice by convention in the degree of that vertex. So इसलिए हमारे पास twice the number of edges आ जाते हैं, ठीक है. Is it fine?
Yes.
ठीक है. So you can write in this way the proof of this. So ये याद रखना है कि इन अ सूडोग्राफ या कोई भी ग्राफ के अंदर भी अगर सूडोग्राफ में है तो ग्राफ में भी है. So corollary लिख लेते हैं so that you can corollary for any graph G, summation degree v belonging to Vg is equal to twice the number of edges. So sum of degrees is an even number, that is, ठीक है, sum of degrees of vertices in G is twice the number of edges. ठीक है, so इसका सबसे इंपॉर्टेंट रिजल्ट क्या है कि अगर हमारे पास कोई भी डिग्री सीक्वेंस दी हुई है, मतलब दिया हुआ है कि तुम्हारे पास जो एक कोई है जिसमें वर्टेक्स की डिग्रीज दी हुई है, तो अगर वो सम जो है इवन नहीं आता है तो देन यू कैन डायरेक्टली से दैट इट कैन नॉट बी अ ग्राफ और इट कैन नॉट बी अ सूडो ग्राफ. ठीक है,
Yes, sir.
so अगर तुम्हें कोई ग्राफ दिया हुआ है कि ग्राफ हैज 8 vertices of degree 3 each, then how many edges are there in that graph? तो उसमें कैसे बताओगे? Question: if there is a graph of order 8 in which each vertex is of degree 3, and what is the size of the graph?
12.
12, right? So solution, how you will do it? You know that twice the number of EG is equal to summation V belonging to VG degree V. So this is because there are 8 vertices, right? So V belonging to VG, ये 3 हो जाएगा, हर एक का डिग्री 3 है. So क्योंकि there are 8 vertices, so this is 3 into cardinality of VG, which is equal to 3 into 8, which is equal to 12. Oh, sorry, 24. Right? So the number of edges is equal to 24 by 2, which is 12. ठीक है? Is it fine?
Yes.
So this is how you can apply this Euler's theorem. इसका एक और corollary है that a graph will have even number of vertices of odd degree. Corollary, ठीक है? A pseudograph G always has even number of odd vertices. Odd vertices means vertices with odd degree. How you will prove this? Let V1 be the set of all odd vertices and V2 be the set of all even vertices, right? Now by Euler's theorem, twice the number of edges is equal to summation V belonging to VG degree of V, right? So this can be written as V belonging to V1 degree of V plus summation, हमने अलग अलग कर लिए, V belonging to V2 degree of V, right? V1 कहते हैं अपने set of odd vertices. So from here what we will have, summation V belonging to V1 degree of V is equal to twice the number of edges minus summation V belonging to V2 degree of V. Now what about this? Is it an even number or odd number?
Even.
Why? Because ये
Degree of
सारे
V2.
even है, ये even है, ये number even है, ये सब ये पूरा even हो जाएगा. So overall this is an even number, right? So this implies summation V belonging to V1 degree of V is an even number, right? और हर एक डिग्री odd है तो एक नंबर का भी even होगा. Every degree is odd. So when this will be an even number?
When there are even number of vertices.
Yes, so this implies since each vertex in V1 is of odd degree, hence, for sum to be an even number, we need to have even number of vertices in V1, right? So that is cardinality of V1 is even. Okay, so hence proved. Hence, in any graph or pseudograph, number of odd vertices is even. ठीक है, ये रिजल्ट हम अभी यूज करेंगे नेक्स्ट क्लास में. we will use this result that in a graph the number of odd vertices are even. ठीक है, so tomorrow we will use this result. Okay, so already we are above time. So any questions from anyone?
No, sir.
Okay, so then I am ending this class. Bye everyone, have a good day.
Thank you, sir.
Thank you for watching this video. To stay updated, please subscribe to our YouTube channel, Cosmos Learning. Happy learning through Cosmos Learning. To watch more, click on any of these cards. Thank you once again.